Evening, everybody, at Environmental Coffee House, and thanks for joining us tonight. Tonight, I am really happy to have with me Patrick McNulty. Patrick is very, very inventive. Patrick has an idea that he's been talking about for a while. I came upon Patrick in a lot of the groups that we're in, Arctic Sea Ice, and then he created his own group, Ocean Tunnel. And he explains about this whole process that can make a difference with Arctic ice. But why, you say? So I'm going to start out with something before I formally introduce Patrick McNulty. Hello, Patrick. I'll formally introduce you. And I'm going to read something quickly to everybody, and then we'll get going. This is a quote by Paul Beckwith. The extreme weather events will ramp up significantly. If we think they are bad now, we haven't seen anything yet. They're going to get a lot worse. And then as the Arctic thaws, there's going to be something that absolutely terrifies the public. They'll be screaming at politicians and scientists, "You didn't let us know this was happening." Politicians will have to take very rapid action if they haven't done so before. I think it's important for the media to start bringing this message to the public. Why wait until we lose the sea ice completely? It's a done deal. Is it going to happen? There's a very small chance it could happen this year. It may happen next year. It's going to be before 2020 based on the trends, and then the public will panic. So why not get strong action done now? Why not get governments to declare a climate change emergency? And given that that was a really excellent quote about the seriousness of this matter, the Arctic sea ice melting is probably one of the most serious issues that we have today in the planet, doing from our burning of fossil fuels. Given that, Patrick is here with us to explain all about the ocean mechanical thermal energy conversion process. So Patrick, welcome. And why don't you get started and give us a little bit of your background, how you got to this point?
Okay. So welcome. I worked for Florida Power and Light for 20 years. And Hurricane Hugo back in 1988 got me interested in hurricanes. So my idea basically came from trying to figure out a way to cool the ocean sea surface. So I came up with this idea with an underwater suspension tunnel to where if you anchored it to the seafloor off of Miami in the Gulf Stream, the cold water from down below would flow through this tunnel up to the surface and mix with the warm water at the surface, thereby cooling it. So if you had a string or a row of these tunnels across the whole width of the Gulf Stream and cooled it 2 or 3 degrees, and a hurricane passed over that, it would cool it. And the Hurricane Center in Miami basically said, yeah, you could do that with it, but it's going to cost a lot of money. So I thought, well, what if I made electricity with it at the same time? So that's what my idea was. I came up with the idea of using the heat in the ocean through it's called ocean thermal energy conversion to boil a fluid, anhydrous ammonia, to spin a turbine, make electricity out of the heat differential, which Paul touched on the other night during his interview. It's like a heat engine. So if you can do that, make electricity with it, at the same time cooling the sea surface temperature, you do 2 things. You help cool the planet through land sea interaction. Cooler waters cools the air that flows over it, coming out of the tunnel. plus you're making electricity that drives fossil fuels off the grid. That's just with the heat energy. Now, there's enough heat energy in the Gulf Stream to power the civilized industrial world over 100 times. So that alone can do it. But it's very inefficient. It's only like 7% efficient in converting potential energy. Well, you can up that up if you combine it with mechanical energy or kinetic energy. So I got the term ocean mechanical thermal energy conversion. So you can use these turbines that make OMTEC much more efficient, 10 times more efficient than it is now. So it's not like this big, long, giant tunnel that's going to go all the way to the Arctic. They might only be 100 yards long, but they're anchored to the seafloor, and the cable goes up to the surface, and the energy extraction's up near the surface. It's not nowhere deep.
Okay.
And so I came up with that idea, and the amount of energy is enormous. You can displace all the fossil fuel and nuclear fuel from being used on this planet just by the heat and kinetic energy that's in the Gulf Stream.
Well, that's a pretty tall order. Wow.
Right. And that's the direction we want to go. We don't want to put more fossil fuels because we know what it's doing to the Arctic. It's melting all the Arctic ice. So that's geoengineering. That's called chemical geoengineering our planet. This would be geoengineering also, but it moves it the other way, where we gain ice in the Arctic. The more ice we get, the more albedo effect we get, so the cooler the planet will get.
Explain the albedo again to those who are with us, in case there's
That's
somebody
when light hits a bright surface and reflects the radiative heat back out to space.
Okay, right.
So the more ice you have, the more light is reflected back into space, thus helping to cool the planet also. So that's basically what my idea is. Now, it's more involved than that. There's a lot of engineering involved with it.
Well,
try us. And computer, I'd love to get it computer modeled, the idea. Both what it can do with the climate and actually how to build it. How many do we need, So,
well, tell me about that. How you don't know. So you've thought of the whole process, but you don't know what it would take or how many it would take or how would you see
I got an idea how many it would take to weaken a hurricane, according to Hugh Willoughby at the Hurricane Center. He's now at FIU, Florida International University. He's a professor there. He said 20,000 tunnels would weaken a hurricane.
20,000 tunnels. Okay,
yeah,
so
there's more power plants than that. So it'd have to be a complete changeover of how do you
so what do you envision in this complete changeover?
No more fossil plants, no more fossil fuels. Because think about it, if it can create enough energy for civilization, the heat energy is there. We already know that. So all we got to do is convert it. Now, when you convert that energy, you can use that energy you're right there in the ocean. You can hydrolyze the seawater. You can make hydrogen with it. So that's a fuel source we can use.
Okay, for what? Vehicles?
Clean energy.
Energy.
That's one of the cleanest energies you can make. You burn hydrogen. The byproduct is water.
Wow.
So
that's really interesting.
You don't get fossil fuels. Particulate matter or stuff like that, or CO2. You just get water when you burn hydrogen. Also, let's see. And with the hydrogen, you can do anything. You can ship it. You can make it there and ship it anywhere in the world. So you can run cars with it. You could charge batteries with it. You're making electricity, so you can convert the AC power to DC power to to run all the Teslas in the world.
Really?
If you, yes.
This. How come nobody's doing this?
Ship them out.
How come
Charge your batteries there and ship them wherever you need them.
Oh my gosh.
You know.
Mm-hmm. But nobody's doing this. How come?
No. Well, they don't know about it. That's why I'm here. Get the word out.
That's what we're doing. And I'm hoping that we can. This is the beginning for you, but we need to do things pretty fast. Right. Let me ask you a question. How long do you think we have before something like you're proposing absolutely has to be created and put into action?
Yesterday.
Yeah, I see. Yep.
We're too late. We're not too late, but we got to get a move on it or we're going to lose the Arctic. And then if we lose the Arctic ice, then we lose the methane too. Just like in that movie, Downsizing. You see the movie Downsizing?
I don't know. I don't think so.
It's kind of a boring movie, but it had the theme or the plot of it was, you know, we've got to do this because we just let a big methane burst go out.
Yeah, we did.
So they had to start downsizing.
So what you're being that this is so critical, you're in the beginning process. You've got to then find someone to work with to computer model this, write a proposal, and maybe
the university. The university, hopefully.
Well, usually, and if you want to get funding, you do an RFP. You look for requests for proposals that are looking for things in your technical expertise. Something just like this, maybe you can get funding for this. This is important. We do have a question from Brian. Hi, Meryl. Meryl says, really quick, that's a great movie. Okay, so Brian is asking the question, the heat gets dumped in the deep water. Is that correct? Patrick.
The heat gets mixed at the surface. So you're mixing the cool water near the surface with the warm water. And let's say the water is 90 degrees coming out of the tunnel and you mix it with 50-degree water coming up. Well, that lowers the average temperature coming out of the tunnel. So instead of 90-degree water, you might have 70-degree water. Well, when the atmosphere hits that at the sea surface, what's that going to do? It's going to cool the atmosphere too, because you have that air-sea interaction. That's the best way I can.
Air-sea interaction.
Correct.
Interesting.
It's only right there at the surface that you're getting it, you know. But
so
one cools the other, or one warms the other.
But this is it is geoengineering, but it's not geoengineering with a negative connotation. It's geoengineering with a positive connotation.
Correct.
Okay.
And anything we do is actually anything we do to change what's happening on the planet is basically geoengineering. It could be a mechanical, let's see, temperature. You know, anything we do to change that is going to be geoengineering.
Right.
Now you can do it and keep getting warmer and warmer and warmer, or you got to do something to make it less and less and less to where we build more ice. And the computer will tell us, you know, what's the equilibrium, basically. We need to reach an equilibrium that's safe.
Okay, explain that. So explain that, how this then would you'd start this going, and then how long will it take for the desired effect, the equilibrium, as you say?
Well, it depends on how much fuel you remove from the grid, whether it be fossil fuels or nuclear fuel, right? So if you do that, the plant's going to want to already cool because you're putting less CO2 in the planet. You're putting less heat into the climate system. And then let's see. Once you do that, the Arctic ice will start building up, and you increase your albedo effect once things start to cool off. Now, the thing is, you can't go too far with it. If you go too far with it, you go the other way. You can get into an ice age. You don't want an ice age. You want to be
no. So it's like another process that has to be managed by human beings, obviously.
It'll be regulated. It's like your thermostat. You know, your air conditioning unit. Mm-hmm. It's got a set point. So all these tunnels got to be put into a computer system that regulates the set point of how much cooling you want to do with these devices.
That is.
I don't want to create an ice age. I want equilibrium. You know what I mean? Mm-hmm. And on the other side of it, we don't want an oven either. We don't want to live in an oven, and we don't want to live in an ice box. We want to live in a refrigerator.
We want to live on a clean planet. And, you know, when I was doing the research, I kept thinking about behaviors, and this has to coincide with a humongous behavioral shift. And correct. How do we, I mean, you know, you have the technology in here to be proposed and hopefully experimented with. How do we do the other? How do we do the other?
I think the computer will give us a lot of the answers. It'll tell us
how we change people's behavior.
Well, we know what's going to happen if we don't, right? So that should lead to a change of behavior right there, you know? Now, but the computer can tell us things, a whole lot of things like how many of these devices do we need to build? Right. How strong do they need to be? How much energy each one can make? You know, how much heat can remove? How much, you know, things like that, basically. It's fascinating to me, and it gives me a bit of optimism. There was someone in, I'm going to read this to you as I prepared a few things, if I can get it. Okay. Someone did ask you a question in one of your, okay, this person, it was a comment, and they said, sorry, you cannot change what's happening in the West Spitsbergen currents. At present, there are 2 SST hotspots cutting further than I have seen in a 12-month Navy loop, which is sea surface temperature. Could you answer to that a little bit? That was in one of your posts. Somebody said Okay, so we know we're burning fossil fuels. We know we're changing the ocean currents, right? And these ocean currents are getting up into the Arctic. They're hotter than what they should normally be, and it's melting Arctic ice. So if we remove the fossil fuels and cool the surface a little bit, then we know things should normalize or turn to equilibrium again. Basically, that's how I'd answer that question.
Okay, good. Mm-hmm. And there was another thing I also wanted you to explain while we're here. You made a comment about PIMAS, which I'd like you to explain to our audience. And you said they lie. You cannot have record low extent and thickness simultaneously without having record low mass. Physics says so. And then you said, OMTEC, anybody? Folks? So how about that? Explain what biomass is to those that don't know.
Okay.
And where do you get all your data? Where do you get all your data?
Okay, that's at the University of Washington, and it's measuring the ice mass in the Arctic. So it's basically what I just said it is right there. Their mass measurements is greater than what it should be because of the amount of extent that we have. We're at record low extent. So if you're at record low extent, you can't have a greater mass than what they're showing. You know what I'm saying? Mm-hmm. On their graphic.
So
it's the University of Washington. If you go there, PIMAS, they have a website for it, and you can look at all the graphics that are there on it.
I'll put that up afterwards. I'll put the links up that I have. Brian has another question, and his question is, are the hurricane cooling calculations available? That seems like a good starting point.
I know who would have them would be Hugh Willoughby, because he ran what he called back of the envelope calculations on it. And he said my idea would work great for storms approaching from the east to the west, cutting across Florida like Hurricane Andrew did. But he calculated 20,000 of these devices in the Gulf Stream that would do enough cooling. It'd lower it two to three categories. Like if Andrew was a 5, it only hit as a 2 or a 3. That's how much heat it would remove from it.
So being that you're talking about this hurricane information, there are, people that say, well, there's been already severe weather modification. And if you already know about this technology, we know that there have been some weather modification studies in the past. What's going on with that today?
Well, I know that they did. What was that program I talked to you about earlier? It was
Storm Theory.
Yeah, Storm Theory. Yeah, back in the 60s. We know they did that. That's out there. Now, whether they're doing other things like that, I have no idea.
Who would it be?
Who would do something like that? I would say your governments would.
But like,
for sure.
would it be the NASA or the NOAA, or would it be the military doing those kinds of experiments?
Could be, I don't know, maybe DARPA is doing something like that.
You think so? Do you have any? Because I don't have a lot of information myself, but I do know what I read and what people say about things that I don't know about. But maybe just can you go over what that is a little bit really quickly, what DARPA is?
DARPA is like a Skunk Works, or they do secret projects, top secret.
All right.
Stuff.
So that's going to happen. That's probably happened in time immemorial with every government then. But I don't know about severe weather modification, and we won't go there, because really we have to concentrate on what we see and what is real and what we know, and that is the Arctic ice is melting, and you have a technical solution that needs to be investigated, articulated. Do you have any idea of the cost of something like this? Do you have any thoughts at all of something mass scale like this?
I wouldn't have the foggiest idea. But Hugh Willoughby just said it would be. Hugh Willoughby told me that for the hurricane part of it would cost like $20 billion.
Billion? Yeah. Okay. So basically, $1 billion. Then nobody's making hurricanes happen or not happen right now for $20 billion. I don't think, but that's not the focus of this. Gene's saying, boy, we have a lot of heat to be removed if you need that many of those devices through the Gulf.
Atom bombs worth.
An atom bomb's worth.
Right. We're doing 7 atom bombs a second right now with fossil fuels. So that's how many atom bombs we have to remove per second, just to get the equilibrium.
How? Oh, boy.
Paul will tell you. He knows I'm telling the truth.
Oh, there's no doubt here. We're just trying to get the information out. I wanted to bring you on because I know that
Hiroshima type atom bombs. I think that was 13 kilotons. So it'd be something like that.
Wow.
Per second. 7 of those per second.
Meryl said when we talked about the weather, the Army Corps of Engineers. Yeah, actually, they could be doing some stuff. I have no idea because I haven't.
They could actually build it. They could actually build it.
Oh, you got to join the military. Get your idea out there. Well, actually, it's not funny. I mean, truthfully, the Arctic ice situation, and I track it on Torstein's page, the Arctic ice, and to me, it is right up there with the worst things. It is the worst
It is.
thing.
It is. It's terrible what's happening
And
up
what
there.
Paul says and what could happen and people aren't prepared. And that's where I feel the urgency comes in. And I don't want to frighten people, but they're going to be frightened when all these weather events start happening much more frequently, as we've been seeing, and with more severity. Or maybe it's more severity. Maybe it's not the frequency, but it's the severity. But around the world, we're seeing, look at what just hit the Philippines.
Right.
And I read about that.
They're just going to get, those typhoons and hurricanes are just going to get worse. The warmer you make the oceans, make no mistake, there's going to be stronger storms in the future. They're going to ramp up along with sea surface temperatures. Now, if the wind shear decreases as temperatures warm, they'll get even worse. But who knows what the wind shear is going to do?
Can you just do a little bit of explanation about the wind shear and what we were talking about earlier?
Okay, you got the hurricanes. Let's say it's traveling across the ocean 10, 15 miles an hour, a certain speed. Everything's going along real nice and good. But in the upper levels, winds blowing from a certain direction at the top of the storm. So it's basically blowing the tops of the storm off of the hurricane. It's no longer vertically stacked. And so when that happens, it weakens. So wind shear could be a limiting factor, or is a limiting factor, is how strong a hurricane can become.
Okay. It's also a limiting factor flying.
Correct. Yes.
I think we've all heard about wind shear in airplanes, and it's a scary thing. I don't know if it's a totally frightening thing when we're talking about hurricanes, but
the planes start shaking and falling out of the air and stuff like that. Yeah, it's bad. But I was going to touch on another thing about what else the ocean tunnels can do is through the energy they create, it can do a lot of sequestering, like with CO2. There's methods of doing sequestering CO2, nitrogen, nitrous oxide, and methane, the three greenhouse gases that warm a lot. So OMTEC can power those technologies also, which means fossil fuels don't power those technologies, making it worse, putting more CO2 in the air. You're using a green energy source to power those sequestration technologies. You know what I'm saying?
Yeah, I've got some of it. I just want to make sure everybody else does too. That's joined us tonight. Let's see if I can get some. Well, there's not a lot of questions out here. We're earlier than I normally do live interviews, but I think this has been fascinating. I would really like to try to get this out more for you. Any kind of technology or any kind of help that's going to help us and not hurt us is needed.
Is good.
Yes, it is good.
Correct.
Let's see if we have any more questions. And do you have anything else that you would want to offer in this conversation? We've been 30 minutes, and I think we've covered quite a bit.
Sure. One other thing I was thinking was, you know how bad the ocean is getting acidic nowadays?
Yes.
Okay, this here can also compress air. Run a bunch of air compressors, and you can create marine brightening. And as you know what marine brightening is? When you take a bunch of microbubbles, bring it up through the water column, and it whitens the surface of the ocean. And as it gets white, it creates an albedo effect, like the Arctic ice does. All those bubbles like a foam on the surface. And so sunlight hits that and reflects back out to space also, just like in the Arctic. But one thing about those bubbles, you could scavenge them. And as you scavenge them, you can draw off the CO2 that's in the water. That's making the ocean acidic. So you can do that with the ocean. So you're out there in the ocean, you're doing all these things at once to make our climate better. You know, there's multiple things that OMTEC can do.
I just can't believe that nobody is doing anything like this. Although, I mean, it sounds like it could be a little unwieldy. And I do have a question about the mechanics of it and what effects it might have on ocean life, if any.
Okay, that's a good question. I've thought of this too. So you've got this body of water coming through each one of these tunnels, right? You're gonna think, well, what if the turbine blade hits this marine life, aquatic life, and starts chopping it up like a Cuisinart? Well, there's things in a power plant that we can transfer some of that technology over to it. It's called a traveling screen. All it is a revolving screen that goes in front of it, and any sea life gets on this screen and just washed back to the outside of the tunnel again, so it don't get chopped up.
Nothing will happen.
So it shouldn't hurt any sea life, for real.
Oh boy, you've really thought of everything. This is something. It's much different to have you explain it than it is just to read about it on the page. This definitely has helped me with my conceptualization, and I hope that everybody that watches this video will get helped with the conceptualization. We'll be able to ask you more questions when it goes on the YouTube, because I'm sure that there are going to be many questions, coming up.
Traveling string technology is like that in all power plants today. So we have it. All you got to do is transfer it over to this. And another thing we can do is to keep it from corroding is people ask me all the time, what's going to be a bucket of rust? Well, they have a thing called cathodic protection. It's got a carbon anode in there. And the corrosion attacks the anode to where you replace it every year so it don't affect the steel. Your steel does not rust.
In the pipeline. Okay.
In the pipeline. So.
Do they use that in oil pipelines?
In the pipeline. In the saltwater line. See, the power plant has big cooling water lines that run through it to condense all the steam in the power plant. And that's what they use. It could be either salt water or fresh water, but they use this cathodic protection to protect the pipes so they don't get the corrosion in the plant.
Well, I think you've really covered a lot of bases in your whole idea. I'm going to see who has anything else to comment on. Heidi came in. Heidi's a wonderful follower of ours. And she said, we're having terrible ocean acidification problems here in Maine. Our Senator Angus King spoke eloquently about how it's driving our lobsters south. Has anyone heard anything about this? I haven't.
I haven't heard about that, but that's, I just touched on it, what it can do with ocean acidification.
But it's all in behavior too. People's behaviors have to change. So Merrill had said, it cools the ocean. It cools the ocean. Yeah, that's basically what Patrick has said. Well, we've covered the rudimentary science. And we have another comment. Merrill, could that white bubbling effect also help you counteract the albedo effect that's occurring in the Arctic as the ice melts? Good question.
So what's it again? I can't quite see it there.
Could that white bubbling effect also help counteract the albedo effect that's occurring in the Arctic as the ice melts?
No, see, we're going to build the ice in the Arctic, but this would work along with it. It would be like working in conjunction with it to reflect more sunlight out to space. So,
okay.
In other words, it's not going to do anything to melt the ice. Yeah.
Well, I have another question that just popped in my head about materials. To create this, the materials, what kind of materials do you need? And will they be mined? And will fossil fuels obviously have to be used to create the whole thing?
Well, actually, we can use green energy to make the materials. We could use any kind of green energy, solar, wind, OMTEC, Doesn't have to be fossil fuels anymore. We have ample enough green energy out there now that can build these materials.
Yeah, we're going to go solar. I am absolutely going to do it, because even if it's just a little thing, but I want to get off the grid.
Another thing I'll mention is OMTEC can also be used with solar energy, wind energy, or solar thermal energy. Because anything that makes OTEC more efficient will work with OMTEC. OTEC being ocean thermal energy conversion.
Thanks. That was I had read about that. That's just you add another word. Okay. Well, then, do you have anything else you want to add? I think we have a good. Well, I have Brian, and this looks like a good last. Patrick, I would encourage you to go open source as you work on this. GitHub or similar. And thank you for sharing with us thus far. Thank you. Thank you, Brian. And thank you, everybody that came, because this is the first of, I hope, a couple, as Patrick goes on this journey. I hope to help him at least get this out and share this. And Patrick, please give us the last closing statement.
Okay, I want to make OMTEC work for the world and make it a better place by cleaning this planet up. So our grandchildren and our children, so they could live long and prosper. And I don't think we're on that course right now. So
no,
it's just an idea I have. I want climate scientists to really look at my idea and, help me out. I can't do it all myself. It takes teamwork.
Well, let's hope we can get this team going for you. Somehow.
Right.
Somehow.
Right.
All right. Well, everybody, thank you for joining. This will be up on the YouTube also, the Environmental Coffee House YouTube. And Patrick will share it, and I'll put up some links if there are anything else that we need to put up for people that want to learn more, which I hope there are, because this is so critical. Thanks, Patrick. I really appreciate having you. Thank you.
Thank you very much, Sandy, for having me, and Happy New Year.
Peace, everybody. Happy New Year. Bye.
Bye.